G'day team, welcome back to another video. So today we're extending on our trigonometric work, looking at now the tangent function or the tan function. So we've done a fair bit of work with sine and cosine, all right? But now we're going to start looking at our third guy, the tan function. So the tan function is very different to the sine and cosine functions, okay? So if you have your unit circle handy, you will notice that on a few points, tan is actually undefined, and that's because tan is sine over cosine, and if cosine is 0, then we're going to have a problem. So we can't divide by 0, so we're undefined. So at these points here, we actually have vertical asymptotes, okay? So cosine is 0 at pi on 2, 3 pi on 2, and so on, all right? So we need to put asymptotes in there. Now it is 0, okay, at 0, pi, and 2 pi, so on, okay? So it goes through the graph at that point, and it's kind of a little vertical wave almost, okay? So that's the basic y equals tan x function. So the general tangent function, y equals a tan bx take c plus d, where a cannot equal 0 and b is greater than 0. So the principal axis is y equals d, so that would be the point where the function turns. So at a point that looks like this or looks like this, okay? All right, the period of this function is pi over b. So in sine and cosine, the period of the function is 2 pi over b, but with tan it is just pi over b. And the amplitude of this function is undefined, as it does in fact shoot off infinitely up and down. All right. Let's have a look at an example. So describe the transformation which moves y equals tan x to y equals tan x take 3. State the principal axis and sketch both on the same set of axes on the domain 0 is less than or equal to x, which is less than or equal to 2 pi. All right, so describing the transformation now, we're looking at just -3 on the end there. And we know that that's a vertical translation. So vertical translation. Okay, but when we're looking at vertical translations, we're going to take into consideration the sign here. So in vertical translations, if it's a positive, it moves up. If it's a negative, it moves down. Because we've got -3, that means we've got a vertical translation downwards. Okay, downwards of 3 units. Okay, and that is all you have to write. Okay. Remember, the principal axis was y equals d. D in this case is -3, so y equals -3. All right. And then sketch the both on the same set of axes. So I've gone ahead and graphed the original y equals tan of x, and we're going to draw y equals tan of x take 3 in red. So basically all that's happened is these points here, okay, have moved down to -3. All right, so along this line here. All right, so we know that this one has to come out of here and shoots up like that. This one comes out of here and shoots up like that, okay? So I just wanted to take into consideration, so the domain 0 to 2 pi, so we need an inclusive point, arrows here, and then this point here is actually, actually like that, and we've got an arrow there and a nice solid line there, okay? So putting these little crosses in is good as a guide. Once you start doing a few more of these graph type things, you won't have to do that anymore. You'll be able to visualize where they're supposed to go, okay? So hopefully that is helpful. Very basic example. So you do obviously have horizontal translations, dilations as well. So have a bit of a practice of graphing a few different tan functions, and we'll see you in the next video.